This is my 59th video on my work with OO Gauge. See part 1 of this series for my reasons for getting into OO Gauge when I already had a lot invested in working in N-Gauge and I didn't really have space available for a large, fully operational OO Gauge layout. Also see my lengthy series on my N-Gauge railway modelling for smaller and more complex scenery and smaller scale trains running. This part is the 33rd, dealing with my third layout made using mainly Hornby set track. See the prior video, part 27, for my reasons for wanting to try a Hornby set track layout when I already had an OO Gauge layout using Bachmann Easy Track. In this part, as I said I would at the end of my previous video, I will be reviewing in detail the DC power and control of my little Hornby layout, and then demonstrating with locos on the layout itself. Here's a view of the whole layout. Not very complicated really, just a couple of loops with some sidings and a turntable on a board 7 foot by 4 foot. And here's the power schematic of the layout with notes. There's nothing very fancy on the layout in the way of track, just standard straights and curves and standard left-hand and right-hand points. No diamond crossovers or three-way points or anything special. The only slightly special item is the turntable, which is the Hornby R070 powered turntable, and I'll cover the details of powering that in a bit. But first, let's just look at a standard Hornby point. This is a right-hand point, but the principle is exactly the same for left-hand points. The point has 3 connections, 1, 2, and 3. Standard Hornby points are switching points, meaning that the way the point is set will determine how electrical power flows between the point connections. Unfortunately, this gets pretty horribly complicated. Roughly speaking, the points are designed to switch the flow of power when they switch the direction the train will go. So if the point is set so the train will go straight through, power will go straight through. And if the point is set to turn the train to the branch, power will flow to the branch. But it isn't really quite as simple as that. With DC, one rail will be positive and one rail will be negative. And for a loco to be powered, it must have both the positive and negative rails connected through to the controller. Suppose that there's a positive controller connection to A and a negative controller connection to B. Well, C will always get positive from A, regardless of how the point is set. And if the point is set straight, D will get negative from B, so connection 2 will have both positive and negative, and a loco will be able to run there. Now, F will always have negative from B. But if the point is set straight, E will have no connection to A, so connection 3, the turning connection, will have negative but no positive, so a loco will not run there. Now, if the point is set to turn, C will get positive from A always, but D will not get negative from B, so a loco will not run on connection 2, whereas F will get negative from B, as it always does, and with the point set to turn, E will get positive from A, so a loco will run on connection 3. Now it starts to get really complicated when you have points in sequence. Here's a basic example which applies to my Hornby layout. 2 points on a loop with a section of track between them. Since the points are on a loop, both will receive a positive connection to their top rail and a negative connection to their bottom rail at the outer ends, since those 2 ends are connected up to each other round the loop. Now if the points turn in opposite directions, as in the top picture, then the center zone represented by the purple lines will always be powered regardless of how the points are set, since it will always get a positive connection through the right-hand point and a negative connection through the left-hand point, because the points never switch those connections. On the other hand, if the 2 points turn in the same direction, as shown at the bottom, the center zone will only run a loco if one of the points is set straight. Since whilst negative connection will always come through both points, there will only be a positive connection through one of the points if it is set straight. I hope this makes sense to you. Quite honestly, it confused me, but I'm sure now that this is correct. So, now back to this rather horrendous diagram. There are 8 sets of points on the layout, here numbered in green P1 to P8. All of these are standard Hornby switching points as just discussed, except for P8. When I set up the layout, I bought some new Hornby points and some used points, and somehow amongst the used points an oddball got in. I didn't notice this until I'd fixed down the track with cork and trackbed underneath it and started to ballast. Then, whilst I was testing, I realised that point 8 was weird. Point 8 always passes power for both rails between all 3 of its connections all of the time, regardless of how the point itself is set. The Bachmann Easy Track points on my other layout work the same way, actually, and I'm not very keen on it, although I suppose it would make things much easier if you were using DCC and just wanted the same power everywhere, regardless of point settings. Anyway, I suppose I'd better try to explain the rest of this diagram. The points I've already mentioned, P1 to P8. I'm using a dual controller with 2 throttles. Power is fed to the track at 4 places. F1 and F2 in red at bottom left are permanent feeds from throttle 1 and throttle 2 respectively. Whenever the layout is powered on at all, power always flows to these 2 points from their respective throttles. S1 in red at left and S2 in red at bottom right are switchable power feeds. They both feed power from throttle 2, but they only feed power when they are specifically switched on. When I switch those feeds off, which is totally independent of the throttle itself, no power will flow there. The reason for this is that I want to be able to park locos in sidings and have them stay put whilst I'm operating locos on other parts of the related track. There are 2 isolators labelled I1 and I2 in green next to the 2 switch power feeds. This means that I've specifically arranged that no power can flow across these points. I1 is done with plastic isolating rail joiners that connect 2 sections of track but don't pass any power. I2 was actually done by using a rotary tool to cut a gap in one of the rails because I didn't realise I would need an isolator there until after the track was laid and ballasted. If point 8 had been a standard Hornby point, there would have been no need for I2, as power would never have flowed across point 8 in that direction. There's also another isolator, I3, between points P5 and P6. This ensures that power cannot be directly connected between the 2 throttles, as could otherwise happen with both P5 and P6 set to turn. The purple lines and Z numbers identify the various distinct sections of track on the layout to allow clarification of how those sections will be powered. Z1 is the main inner loop, except for the front section that is separated off by points P3, P4 and P5. Since the permanent power feed F1 feeds directly to Z1, Z1 will be powered at all times, and any loco on that section should always respond to throttle 1. Z3 is the section of the inner loop over the level crossing between points P3 and P4. This is the section I had some trouble with in my train cam video previously. This section can get power from F1 either through P3 if that is set straight, or through P4 and P5 if P4 is set straight. It doesn't matter how P5 is set because P5 turns in the opposite direction to P3 and so can only cut off the rail that is always passed through P3, as previously discussed in the example with 2 points on a loop. But if P3 is set to turn and P4 is set to turn, no power will flow to Z3, as its far rail will be cut off by the points at both ends. Z4 is the branch to the turntable and also includes the turntable itself, since the Hornby R070 turntable draws its power for loco movement from its feeder track. Z4 will get power from F1 so long as P3 is set straight and P4 is set to turn. Only when Z4 has power will it be possible to move locos on the turntable and its various parking tracks. The line on the rotating table itself will always be powered whenever Z4 is powered. The various parking lines will only be powered when the rotating table is actually lined up with them, as they draw power from contacts touching the ends of the rotating table, so long as those contacts work, which They didn't always when I was first setting up the turntable, but they seem to be working fairly well now. Note that the rotation of the turntable is a separate issue. The powerful rotation of the table has no connection at all with the throttles. The power for rotation comes from a completely separate 12-volt transformer and is controlled by a simple switch. Whenever that switch is turned on, the table will rotate, and as soon as that switch is turned off, the table will stop rotating. Turning the rotation power on and off is completely independent of throttle power to the tracks. Z5 is the start of the branch to the internal sidings and the goods shed. Power cannot flow to Z5 from F1 through P3, that's down to power never flowing for both rails between connections 2 and 3 on a standard Hornby point, as previously discussed. So for power to get to Z5, the power has to flow all the way round Z1 clockwise, and then through P5, P4 and Z3, and finally P3. So Z5 will get power from F1 only when P4 is set straight and P3 is set to turn. Again, the setting of P5 doesn't matter as it switches the near rail, which will get connected by P3 from the left when P3 is set to turn. Z6 is the line to the goods shed. It will only get power when Z5 has power, as just covered, and P2 is set to turn. Z7 is the other internal siding. It will only get power when Z5 has power, as covered, and P2 is set straight. Everything discussed so far has been powered via F1 from throttle 1. Z2 is the main outer loop, except for points P6 and P7. Since the permanent power feed F2 feeds directly to Z2, Z2 will be powered at all times, and any loco on that section should always respond to throttle 2. P6 and P5 allow trains to move across between the inner and outer loops. If P5 and P6 are both set to turn, a train can move from one loop to the other, but power never flows across because of the isolator I3. So when moving a train from one loop to the other, it's necessary to set the throttle of the receiving loop to match the throttle of the sending loop before the train starts to move across points P5 and P6. Z8 is the main section of the outer siding. It gets its power from throttle 2 feeding at F2. To get to Z8, that power must potentially flow through P6, P7 and P8. For Z8 to get power, P7 must be set to turn. It doesn't matter how P6 is set because that switches the far rail, which is always connected across P7 from the left. It also doesn't matter how P8 is set for power flow since, as discussed, P8 always passes power for both rails in all directions all the time, no matter how it's set. So Z8 depends only on the setting of P7. Whenever P7 is set to turn, Z8 will get power. Z9 is the left outer siding, going to the left line of the double engine shed. It gets its power from Z8 through P1. So for Z9 to have power, Z8 must have power as just discussed, and P1 must be set straight. Z10 is the right outer siding going to the right line of the double engine shed. It will never get power from F2 because it is isolated at its end by I1. Z10 will only get power when the switchable feed S1 is switched on. That power still comes from throttle 2, but directly via the switch, not through F2. Similarly, Z11 is the head shunt, and it will never get power from F2 because of the isolator I2, which is necessary because otherwise the weird point P8 might try to feed power to Z11. Z11 will only get power when the switchable feed S2 is switched on. That power still comes from throttle 2, but directly via the switch, not through F2. Well, I'm sorry if all that was really extremely convoluted, but hopefully it does all make sense. Even though it took me a while to work out myself. Now let's see if I can just demonstrate all of this by some mucking around with locos on the layout itself. Okay, let's see if I can demonstrate the powering of this layout in reality. Okay, so this is the inner throttle, and I've got the little Lima engine on there. Let's go the other way to start with. Okay, it is now on zone 1. There's a power feed here, and it will go round zone 1. Now, as soon as it comes past that point here, it's really no longer on zone 1. Now it's on zone 3. Now, if I set those 2 points to turn, it will not now move when I turn up throttle 1. If I set that one, it will. Famous last words, it will. I'm just going to give it enough power. Now, notice that it does not matter. Oops, signal over. It does not matter how I set that 0.5. I just set that 0.5 to turn, but the engine still moves on zone 3. Because 0.5 is switching the near rail, and that near rail is always connected through 0.3. So it doesn't matter what 0.5 does. Now if I go up here, I'm getting power through P3 turning and, lost my diagram, P2 there. And if I go the other way, oops, I'm going to go a little bit further I guess, and turn P2, then I can come up here, and of course if I turn P2 the other way, then the engine won't move when I turn up the throttle, but as soon as I switch the power, the point over, it will. With a bit of luck, hopefully that sort of demonstrated what's going on with zone 3 and those sidings there. Okay. Now I've got the little pug here on zone 8, the outer siding, and he's readily moving when I turn up the outer throttle. If I change 0.7, then he will not move. See, nothing happens when I change points, when this 0.7 is set to turn. But, doesn't matter the heck what I do with 0.8, because 0.8 doesn't switch power. And perhaps less obviously, it doesn't matter if I can reach it, what I do with 0.6 back there. It's not going to make any difference. It doesn't make any difference what I do with 0.6, because 0.66 is switching the inner rail, but the inner rail, the power through the inner rail is always coming through here. See, it comes through from the other side here, and then through 0.7. So it doesn't matter how 0.6 is set. Okay. Now, this is zone 10, which is switched. These two switches, that switch switches zone 10. So if I take the point, but as soon as I turn the switch off, nothing happens because that is switched. And as soon as I turn the switch back on, it will move. Now of course, turning the switch off doesn't have any effect once you're past the point, because in fact once you're past the isolator. Okay, let's cheat a little just for a moment and take that off, because there is actually an engine in the engine shed down there. If I set that point straight, now I've got to remember which way we were going. I get confused. Yes, we're going the right way. So if I now set that point straight, that's point, whatever is that? That's point 1 in fact. We've got power to zone 8. When I set that straight, that lets the power go through to the engine shed. So now we should be able to bring these engines in the engine shed out. And we can. But as soon as I turn that point off, that cuts the power to there off. I think we've pretty much shown all the zones now, haven't we? Let's turn the P2 power off. Now, of course, I'm not dealing with derailing issues here, I'm just dealing with how points are set. So now I've got the little pug on Z zone 2, basically. Z2 is getting power, it's almost standing right over the power feed, in fact, at the moment. And that should go all the way around here. Zone 2 is all one zone except for those 2 points there. And if I turn this point back again and reverse him, we can bring him back onto point 8 again. Now, if I change point 7, now he will not move. And let's just see if we can move the diesel over to the outer loop. Okay, so what's the diesel doing? Okay, he's going in the right direction. So what we'll do is we'll put some power on the outer loop in that same direction. We've got both of those points, P5 and P6, set to turn. Famous last words, now he's just got randomly stuck. I don't think that's because he's not getting power, he's just randomly stuck. Didn't work. It didn't work. I'm not really sure why not. Apparently we're supplying power, so why is he not moving? Oh, just dirty track, I'm afraid. Okay, well let's try and see if we can do it the other way. Turn 1 up. Oh, for goodness sake, now he's decided he doesn't want to go there. I don't know. I did this when I was doing my other running the other day. I actually got this to work. I do have it in the right direction. It's just, I don't know. It's not easy to get him. I was sort of surprised the other day that I got him to run across there. No, I just cannot get him to run across there. And he should, really. He really should. And the funny thing was, when I was doing my train demonstration the other day, I actually got him to run across there correctly several times. But now I just can't seem to do it. And it's not, there's no sensible power reason for this, it's just, there we go, I got him across. It's just because you've just got to have enough power. And there is a bit of a dead zone in the middle, you see, when you go across those 2 points. I don't know, and I guess it needs cleaning. That shouldn't be on the dead zone. There's always something. Really, I'm not succeeding in getting him across here at all, and he really should. Of course, a longer engine, something with a tender and tender pickups, would probably go better. No, I just cannot get him across. The principle is sound, but I'm not managing to get it to work. sort of work there. It's hard getting engines over crossovers. But hopefully, oh, I didn't really take anybody up to the turntable, did I? See, if I take him up to the turntable, he will get, but he won't get power if I turn P3 to turn, because P3 cuts off the rail he needs, and of course if P4 is not set to turn, he won't get power. But otherwise he will get power. I guess we can put him on the turntable itself. Again, won't get any power on the turntable if P3 is set. And what makes the turntable rotate is this switch here. So, if I get that to a vacant line, I might be able to run him off on it. Yes, I can. There you go. I ran him off on that. But of course, again, as soon as I switch P3, he won't get any power there, because P3 is controlling the passage of power to there, as is P4. But if I switch P3 back, he should get power, and if he does. There you go. And let's just bring him off the turntable again. Now, which direction do I need to go in? Oh, not that one, clearly. There you go. Okay, well, I think we'll have to consider that complete.